So that picture is, so I study at University of Guelph, as you mentioned, but I'm a part of a lab called the Controlled Environment Systems Research Facility. And essentially the lab was started with the focus on one question: is how would we grow plants in space? And if we have to grow plants in space, then we would need certain systems that accompany the whole infrastructure. And born of that question, the lab started its research project, and it has our lab has done many research projects on this topic. But recently, because there's news with the Artemis program, humans are going back to the moon, and then eventually even Musk is pushing the move to Mars. The interest in extraterrestrial habitation is increasing, and if the one thing that we need for any of this to work is food, because humans cannot sustain themselves without food. And when you are on the moon or the Mars, you have to grow your own food. There's no way around it. The cost of taking food and raw materials from Earth is prohibitive. It's time consuming. So
very expensive.
Exactly. Yeah. So what? $10,000 per kilo or something like
kilo,
that? Yeah.
Right.
The astronauts have to grow their own food. Because this is becoming such a hot topic, NASA and the Canadian Space Agency, they sort of jointly called this competition called the Deep Space Food Challenge. And essentially the goal is to develop a system under a given set of constraints. So they had constraints on volume, energy, water, time spent on the system, etc. You have to build a system that can sustain 4 astronauts for 2 years. And as part of our entry from our lab, we developed a system called Canada GOOSE. And GOOSE here stands for Growth Options for Outer Space Environment. So the picture that you're seeing is a prototype of that GOOSE system. And essentially what it is the final version of it is a refrigerator-sized growth chamber in which you can control all the environment conditions. There are LED lights that provide lighting for the plants to grow. And we can grow plants in a hydroponic setup, essentially without the need for soil. We can grow different kinds of crops, from lettuce to microgreens, tomatoes, radishes.
Nice.
Cherry tomatoes, yeah.
So you are taking part in something called Deep Space Food Challenge.
Yes.
So tell me about that competition.
The competition was to call for designs from companies, institutions, or even individuals to develop a system under a given set of constraints. The main constraints were on mass and energy, and also volume. The system has to be under 2 meter cubes.
2 meter cube.
Yeah, of volume. Think roughly of the size of a fridge. Energy, the lower the energy, the better. Energy consumption. Water, the lower the better. And also crew time. So you wouldn't want astronauts to be spending hours a day. The ideal suggestion was 4 hours per week.
To maintain and operate that system.
Yeah, to maintain, operate, clean, harvest, everything. And there's no limit in terms of what you can grow. So that was the competition. So it was launched by NASA on the American side, and then Canadian Space Agency on the Canadian side. The systems that were submitted ranged from growing algae and using algae for food products, growing insects, and then harvesting the insects for insect protein. There was a yeast-based system where you can use the yeast to create other products.
Through genetic engineering.
Yeah, so you're using yeast to make bacon or something like that. And ours was because we have our expertise in plant production. So ours was mainly a plant production center. We also had mushrooms in the system. So the top 70% was growing plants, and then we had a bottom unit that grew mushrooms. So that way we supplement. The whole thing took about 3 years. So the first phase was just coming up with a proposal and a design. Second phase was building a prototype, and the third phase was building the actual system. So along the line, there were a lot of students were part of the team, and I think as a group, we had amazing students who were really capable, and we all designed the system. So it's by no means my work, but the teamwork.
Okay.
Yeah.